All right, folks, if you're tuning in, we'll be starting here in just a minute, talking about Istio, service mesh, and ambient mode running on Amazon EKS. Really excited for my guest speaker today. Be sure to catch us starting in just a few minutes. Cut the music. Hello, everyone. Welcome to another episode of Containers from the Couch. Today, I've got the light board. I'm going to be doing a quick architectural overview of Istio Ambient with my guest speaker, Ram Vennam. Let me go ahead and bring Ram on right now. Hey, Ram, how are you doing?
Hello, brother. Mom says hi.
I'll make sure you tell her hi back. I'm excited to see you this weekend, by the way. I know you're coming to visit me here in Austin, so this will be fun. How are you doing? You excited?
I'm great. I'm super excited. Happy to be on here again, talking about my favorite topic. But
awesome. I love when the things that we work on happen to overlap and intersect. I get to bring my brother on Containers from the Couch. That's pretty cool, if you ask me. Folks that are watching from home, drop a comment in chat. Let us know where you're tuning in from. And if you have any questions throughout the episode, don't hesitate to drop a comment. If I miss it, I'll definitely come back and grab it before the end of the show. Today, we're going to be talking about Istio, service mesh, and ambient mode. And I was very careful with my wording there, and especially when working with containers on Amazon EKS. Ram, tell us a little bit about Istio itself, why you think customers have such a demand for a service mesh, and maybe a sneak peek into what we're going to start diving into today.
Sure. Yeah, I'm happy to. So hi, everyone. So my name is Ram Vennam. I work at Solo.io as a solutions engineer. So I help our customers adopt a service mesh to solve a wide variety of problems. I help them build like distributed systems that have automatic failover and HA principles built into them, and service mesh is a very key part of building out that type of architecture. The number one reason why users typically start looking at a service mesh is for security. And then the second big reason is like traffic control and observability. So like users typically fall into those two camps. From a security perspective, they're leveraging a service mesh to improve their security posture without making any changes to their application codes, to their application developer workflows, etc. So can you transparently in the network add security so you can get that zero trust posture, establish access rules on who's allowed to talk to who, etc. The second big camp, the traffic management folks, these are people that want to have advanced traffic control and functionality into the network, being able to redirect traffic on the fly, depending on if there's a failover, maybe they want to do canary deployments. All of this intelligent network logic is another set of big feature use cases for the Istio service mesh.
Okay, excellent. Now, specifically, Istio itself has gone through a lot of different iterations. I've seen it kind of go from its early stages in 2018 to where it is today, kind of a much more kind of robust, mature solution. I really like the fact, by the way, that you called out that these advantages Istio offers, things like mutual TLS, the improved security posture and footprint, are possible without necessarily having to make surgery with application code and injecting all sorts of different changes into the app. You're leveraging the network layer to do that. Now, that being said, up until today, Istio has taken an approach of using sidecars. So maybe we can start today by just kind of quickly sketching out what the sidecar-based approach of Istio looks like. And so I'll start this by maybe drawing out 3 different application components, let's say A, B, and C. Let me leave a little space in there for what I'm going to draw in as the sidecar. And Let's actually put these in nodes as well. Worker nodes, or the data plane in Amazon EKS, basically EC2 instances where these applications end up actually running. And we'll have a sidecar in this as well. So Ram, help me walk through how in a traditional kind of sidecar-based Istio deployment on an Amazon EKS cluster, how communication works.
Sure. So regardless of the node, regardless of which node the pod lands on, whenever a new pod comes up, Istio uses a webhook to inject an Envoy proxy next to every one of your containers. So in your pod, you might most likely have one container, which is your application container. Now you'll have two containers, the second container being the Envoy proxy. And that happens for every single pod that's added to the mesh. It's transparent, it's automatic. So whenever a new pod comes up, it just gets injected automatically.
Okay, excellent. And so when these components now need to speak to each other or speak back to kind of the Istio kind of control plane, as they call it, or data plane, I'll draw that component.
Control plane is good. Istio-D, that's the control plane. So we typically refer to the workloads A, B, C, those pods as the data plane, and those envoys are basically the data plane as well. And then the control plane, Istio-D, is responsible for programming those envoys. So if you say A is allowed to talk to B, and when B talks to C, I want you to add this additional header to it. Those are all things that you apply as Istio APIs, so Kubernetes resources. Istio-D will take that information, convert it to Envoy language, which is lower level than the Istio API, and then push that configuration to each one of those envoys. And that happens dynamically. So every time there's a new configuration, it immediately gets pushed to those Envoy sidecars. So, and then the second piece was, obviously security. Every one of those envoys will have a strong identity that's associated with that service account of that particular pod. And that identity comes in the form of an X509 certificate. So Istio-D, the control plane, acts as a CA. Whenever a new pod comes up, the envoy and the Istio agent will talk to Istio control plane and say, hey, give me a certificate that represents me, my service account, and then they'll get a new certificate. So now when A wants to talk to B, those envoys next to A and B will use that certificate to establish connection, and you have MTLS between every single hop.
Okay, so if I understood that right, first envoy, make that communication with Istio-D to get the CA certs and everything. So now when A needs to talk to B, the envoy proxy is able to communicate directly to B over kind of an authenticated path.
Correct. Yep. And that would be, that's an encrypted MTLS traffic that's happening to A to B. And that's what gives you like control. So now you can say how you want traffic to look like between A to B.
Got it. Okay. And so this makes a lot of sense to me, but for better or worse, Istio is taking the direction of now supporting an ambient mode. So why is the sidecar approach less than perfect?
Yeah, that's a great question. So there's nothing inherently wrong with the sidecar approach. So Istio was launched since 2017. Since then, we have like thousands of companies that are using Istio in production today. It's been very successful. But there's always room for improvement, right? As with any project, there's always room for improvement in terms of latency, operationalizing it, et cetera, et cetera. And that's really where this comes down to. So with the sidecar approach, there's a few places where we can improve this. First is operationalizing it, right? So when you go to upgrade Istio and you want to upgrade your data plane components, your envoys, you have to do a rolling restart of every single pod. So if you have 10,000 pods, you have to essentially go down the stack and do a rolling restart so you get new envoys. The second piece is the envoy, the sidecar, it's small. It's actually very tiny. But if you have 10,000 pods or more, we're seeing Istio users, have massive environments. Then you have 10,000 little sidecars, right? So like that's a resource usage that you're incurring on every one of your pods. But what if they don't really need it? Like what if you're only using a service mesh for MTLS and you don't need a full-blown Envoy proxy that is very advanced, very capable of doing all of these additional HTTP manipulation, layer 7 stuff. But what if you don't need it, right? And then there's also like a set of people, like theorists, that just don't like the idea of having a sidecar next to their pod, because they see the pod as, this is what I own, this is my container, what's this additional thing? Why can't we do it at a different layer in the stack? So those are the reasons why we were like, hey, can we do this without a sidecar? How can we accomplish the same functionality without a sidecar?
Absolutely. And I think I like the order in which you presented those, because I do almost feel like, at least from the customers that I speak with, that operationalizing tends to be one of those biggest issues or problems when implementing Istio. And by removing the need to have sidecars, by leveraging the network of the nodes themselves, well, we're about to see how that can kind of pose advantages. So
on this, as you draw it out, I like the way you said that, right? If Istio is in the ownership of the platform engineering team, if they want to do an upgrade, they don't want to have any impact on the developers. They don't want the developers to even know about it. That was the premise of a service mesh, is that it can do it transparently. But if when you ask the developers to restart their workload, while it's small, but it's still an impact, right? That they have to absorb the risk of, hey, what if I upgrade my pod and now the new version of Envoy, do I need to retest it again? Are there any incompatibilities? So it just makes the upgrade a little bit more painful than it needs to be.
That makes sense. So here I'm really just sketching out the basic components again that we have. So 3 application pods. A is running on one of the worker nodes. B and C are on a different worker node. And so here we've got an EKS cluster. We've begun to install STOD. Let's talk about ambient mode. How does this work? And notably, I haven't even left any space in here for a Envoy proxy sidecar.
Yep. So you might think, initially the way to solve this problem is just to take that Envoy that's running next to every one of your containers and just pull it out and run it as a separate pod, and then have users share one or more of those instances. The problem with that approach is Envoy is not designed to be multi-tenant, right? Like if you're sharing Envoy across all of the pods, whether it's in the node or the entire cluster, you'll start getting noisy neighbor problems. That Envoy will be filled with configuration for every one of these tenants, and it has to go through its like filter mechanism when traffic comes in. So you don't want to share Envoy with everybody in the node or the cluster. Okay. So what we did was we took that proxy, that Envoy proxy, and we split it. Kind of the best of both worlds approach, where we split it to a layer 4 proxy. So layer 4 being, it's only responsible for things like MTLS, that TCP tunneling and TCP level observability. Just think of it as like packets, being able to do secure packets. And then the other half of the split is a layer 7 proxy for people that need HTTP-based like manipulation, redirection, canaries, and all the fancy stuff that you can do with Envoy, right? So we split the two, and then we looked at each one of those things, okay? The TCP proxy can be small, can be lightweight. It doesn't have noisy neighbor problems because what it does is it's so focused on what it does. You can't program it to do more things than it does. So you can actually safely share that between every node. Between every pods on the node. So every node will get its own layer 4 proxy, and that's called Z-tunnel, a zero trust tunnel. And this was written from the ground up using Rust, and it's purpose-built to do exactly what it needs to do, which is, do MTLS of traffic, and then get some TCP level observability.
Okay, so we have a Z-tunnel. And now this is, again, for layer 4 TCP routing. So not based on, like fully qualified domain names, but really like IP address port based.
Yeah, people that just like, hey, I want MTLS when A wants to talk to B. That's all I want a service mesh for.
Okay.
And I want to be able to enforce policies that A is allowed to talk to B.
So before Istio, let's say Istio's gone, when A talks to B, we don't have that mutual TLS. We don't have that encrypted communication. So with this, how does that communication become encrypted?
Yeah, that's a good question. So what we'll do, what Istio does, the Istio, there's an agent component called Istio-CNI. It's not a CNI. Think of it as it uses the CNI to accomplish what it needs to. It sits on top of a CNI. So what that component will do is whenever a new pod comes up, or for existing pods that are added to the mesh, it will go into the pod network namespace, and it will use IP tables to open up a socket, right? And then redirect traffic that is going in and out of the pod to those sockets. And then it will go program zTunnel, which is in a different pod network namespace, to create a listening socket on pod A's pod network. So think of it as, it's not traffic leaving A and going to C. It's more like it's going underneath the house using like a pipe, right? We're using the lower level kernel to capture traffic and go directly to the host node. So it's not leaving the pod network namespace. So even though zTunnel is in a different pod network namespace, it can create listening sockets on A. So that's how we're able to capture the traffic that's going out of A. And then zTunnel will encapsulate that traffic into this new protocol that that Istio came up with called HBone. It stands for HTTP based overlay encapsulation. So it will take that traffic, it will encapsulate it, it will attach it, to that certificates, right? Because it needs this needs to make MTLS to a connection. It will enforce any TCP policies that you have, like access policies, and then send that HBone traffic, that encapsulated traffic, through A back to the pod A's network namespace, and then it'll go to its destination.
Okay, so the traffic, once it gets here, though, B can't read it just yet, because it's
B. This is HBone MTLS traffic, so B can't read it directly. So the same process happens on the B, where the zTunnel on B's node will capture that traffic in B's pod network namespace. It will decap it, meaning it will, uncap the HBone encapsulation, and then send it back to B. So all this is happening without A and B even knowing that this is going on.
Okay, that's a really important distinction, because notably, as an application developer or even operations engineer that's deploying these components, they don't really need to know that these
anything I just said.
It's are opening, the encapsulation, decapsulation happening. All of this is just happening through these Z tunnels in Istio. And I got to ask you this: is Istio handling all of the requirements for that secure overlay?
Everything I just said, it's all automatic, and it happens. So whenever there's a new node comes up, zTunnel is a daemon set, so it'll get spun up automatically. Whenever a new pod comes up, we'll use the CNI to tweak those listening sockets, etc., inside the pod, those port openings, HBone, everything's automatic. So when you add a pod to Istio Mesh in ambient mode, there's nothing you have to do. You just label the namespace and say, I want the pods in this namespace to be part of the mesh, and that's it. Instantly, you're part of the mesh. You get MTLS out of the box. No updates, no restarts or anything like that.
Okay, that's pretty cool, because in the past, obviously, with injecting sidecars into a pod, you would have to, restart the whole cluster, and that's when you get these things working. So that's interesting. It's able to take running containers, running pods, and create these sockets for the communication to happen. Exactly. Now, Rama, even though it's able to do that, does it somehow prevent the previous network paths from working? So, A used to talk to B without all of this happening, but with Istio, suddenly this flow is required. How does that shift over happen? Is there any implication?
No, it's all transparent. It is completely transparent to the applications. They don't have to know about any new IPs, new host names, or anything like that. Even like the CNI itself, your previous network policies would also completely work. So this is all happening, at a pretty low level. So it doesn't impact anything, essentially.
Gotcha. And that's why we're able to share single instances of these Z tunnels across nodes, because it is such a low level thing. It's such a focused task, as you were mentioning. And so the performance implication here is very little. And we got a question in chat here. When doing this approach with ambient mode, will there be performance improvements?
Absolutely. So now you're not hopping through 2 envoys to get to where you need to go. I'll caveat that and say, like, the Envoy sidecar, it's not slow by any means, right? Like, we've published the numbers. It is 0.2 milliseconds, not 2 milliseconds. If you go look at the performance data on Istio, you'll show it's 0.2 milliseconds of latency that the sidecar adds. But with this new model, it'll be even faster than that.
Got
right?
it.
Because you're not going through Envoy. With the caveat that we're not doing any L7 stuff yet. We'll talk about that. This is only for layer 4. If you only care about a TCP proxy for MTLS, there is performance improvements. Will there be any differences in observability? It'll capture TCP metrics with this approach, but if you wanted more like layer 7 metrics, then we'll need an Envoy proxy somewhere, and that's what we'll talk about next.
Awesome, and the perfect segue to that is the other question here that we got from Yogan48. Where do the L7 manipulations and operations happen? And clearly, Yogan already kind of knows a little bit about ambient and the next thing that we might be talking about here. So perfect segue here.
Cool. Let's say A's talking to B, right? B doesn't need any layer 7 manipulations, so we don't need Envoy. What about B wants to talk to C, but the owner of C wants to do manipulation. So let's say they want to add a couple of headers, and they want to do, if this header matches, I want you to go to version 2 of my service. I have this load balancing properties, etc. So they want to do additional stuff. They need Envoy, and that's what we call a Waypoint proxy. So for just C, whether it could be C's namespace or C's service account, we will spin up dynamically a new Envoy proxy, which will run outside of the pod, not as a sidecar. It will run outside as a pod, as a separate pod. And then we will configure ztunnel, Istio will configure ztunnel to go through that Waypoint proxy instead.
So I'm just going to put W for Waypoint proxy, but this is kind of the Envoy right here.
Yep.
So this gets deployed for us because he wants some L7 capabilities.
Yeah.
Right?
So if you're just using upstream Istio APIs today, you can use the Kubernetes Gateway API to declare that you want a Waypoint proxy for Team C, and Istio will spin that up. Or it could be dynamic, right? So the product I work on, Glue Mesh, will see if you have any policies that need L7, and if it matches any workloads, then we'll spin that up for you. But essentially, yes, you can dynamically do it or you can statically do it, but you will declare your intent that you want a Waypoint proxy.
Okay, so you mentioned one interesting thing that you might want a Waypoint proxy for is more intelligent traffic routing, maybe checking for a header or something. This is something that the ztunnel won't support. That's a bit more of an advanced processing requirement. And so because, let's say, I have 3 versions of C, and based on the header, let's say you're on mobile or a laptop or some other device, you get routed to a different version of the application. So this would be, I think, a perfect use case for an Envoy proxy. And so this Waypoint proxy, now, notably here, I almost expected you to say that, why don't we just deploy that Envoy proxy within a container like we're so used to? But, in the spirit of the ambient mode here, what's the advantage here of deploying this Waypoint proxy as its own, must be a pod, right?
Yeah, it's a pod. I mean, it is a container. It's a pod. It's just not a sidecar pod. The benefit of this approach is you can scale every Envoy, every Waypoint proxy independently. So if application C has a lot of HTTP processing and they need to scale up Envoy, they can do that just for themselves. If another application, let's say application D, has 100 instances of D, but they do very little Envoy processing, right? They don't need 100 instances of the Waypoint proxy. So it gives you the flexibility to scale Envoy independently of your application networking need. Going back to the principles of microservices, right? Give you that flexibility and only stand up what you really need, which is where Envoys as a sidecar kind of struggled a little bit.
Okay, awesome. All right, I think this is about as much as we wanted to maybe show as far as the architectural differences with Ambient, and we got pretty technical here. We were talking about H-bone, encapsulation, decapsulation. So I love that, and we know how this works.
Even more.
No, but that transparency is good because we want to understand what's happening underneath the covers, and clearly there's performance benefits here. And even when you're using the layer 7 capabilities in ambient mode with these Waypoint proxies, still performance and efficiency improvements. So that's very clear. Ram, let's
One
switch.
thing I wanted to cover though. Sorry.
Yep.
What does it mean for the users, right? Like, what does a service mesh and what does ambient really have an impact? Where does it move the needle? It's about moving to the public cloud. It's about moving to cloud native. It's about adopting more Kubernetes clusters, right? What a mesh allows you to do on top of these like in-cluster security and traffic manipulations, what a mesh allows users to do, which is what I've seen big enterprises to do, is a mesh that spans multiple clusters, multiple networks, as well as other computes, VMs on-premise, EC2s, etc. You want a mesh to span all of these so that you can not worry about where a particular workload is running. Today, B might be running in cluster that's on-premise. Tomorrow, I want to move B to my EKS cluster in US West. Day after tomorrow, I might want to move it to this other location, or I might want to have multiple instances of it. I don't want to have to reprogram A and tell it the location of B, right? When you have a mesh that spans your entire network, then the mesh will take care of routing to wherever it needs to go. So a mesh facilitates the adoption of Kubernetes, of public cloud, of EKS. And that's really a big point. Users who adopt mesh will start adopting more and more Kubernetes clusters because they start treating these clusters like cattle. They just spin up and take down clusters wherever they need to and not worry about creating these monolith clusters that they're so scared to touch. So what that happens is that monolith cluster just keeps growing. This allows you to build a data center that is more microservices, right? Like you can grow and shrink whatever you need to do. And if you're moving from on-prem to public cloud, then create a mesh that spans on-prem to public cloud. The benefit of ambient in this, what I just talked about, is that those Z tunnels can seamlessly route traffic to things that are outside of a Kubernetes cluster. So if you have a set of VMs in a VPC, for example, that Z tunnel can connect to a Z tunnel that runs in the VPC and give you that east-west hop to bring your VMs into the service mesh, into the cluster. So now you can route traffic to those VMs the same way you're routing traffic to other services in the mesh. And then over time, you can move those workloads from VMs to EKS.
And that's actually really interesting. And I know that a lot of customers are using projects like KubeVirt and that kind of thing to help bring virtual machines into the context of Kubernetes. Mm-hmm. So the fact that Istio doesn't discriminate between the workload and with the ambient capability makes it, allows you to work with non-Kubernetes workloads as if they're Kubernetes workloads. That sounds pretty cool. I'm also thinking maybe for like Lambda endpoints and that kind of thing, you can also help, let's use mesh. We have a couple of questions here, Ram. So before we jump to the demo, let's maybe cover some of these. A question from Prasida. Hey, Prasida, are we going to cover how customers can migrate from Sidecar to Ambient? And Ram, I just want to add one more thing to this of interoperability. So if I had something like this with one cluster on-prem, one on AWS, and this one's using sidecars and this one's using ambient, what does that look like?
Sure. Let me tackle the single cluster first. In one cluster, you can have both sidecar and ambient workloads. Same control plane, same Istio can program and interoperate sidecar workloads and non-sidecar workloads. So So you can do both. So like some users might stick with sidecars for a while and for some workloads, and some users might do ambient. So we want to make sure that that migration happens seamlessly. Okay. What we're changing is just data plane, like where you run Envoy, where that proxy is running, etc. The API is not changing. We're not rewriting the Istio configuration to a new ambient API or anything like that. And that's why, like, Sai, you said earlier you were careful with your verbiage, because it's not a new service mesh. Ambient is not a new service mesh and a new API. It's the same Istio service mesh. We're just giving you another way to run the data plane. So the API stays the same. The second question was, well, what about like different clusters? Some clusters having sidecar, some cluster are ambient. It's the same as running sidecar or ambient. To join two clusters together that are both running Istios, there's multiple ways to go about doing it. You basically, those two Istio-Ds need to talk to one another, right? So you kind of need to federate one another. They can talk to each other directly, but as you start adding more and more clusters, you're going to start running into scale problems, because that's going to be a very chatty web of communications. Or you can use what we call as a management plane. So I work on Glue Mesh, and Glue Mesh comes with a management plane, which oversees and facilitates the joining of all these clusters. So in that case, every cluster will talk back to the management plane and get back the configuration that it needs to do cross-cluster routing.
And actually, last time Ram was on Container from the Couch, I think a little bit under a year ago,
yep.
We actually talk about multi-cluster with Istio and how to interface EKS Anywhere, which might be running on premises, to EKS. And so I'll make sure that's linked in the description below on YouTube after this episode goes live. But that's another approach where having a management plane can make a lot of sense.
Yep. We work with customers that join 100 different clusters to the management plane and orchestrate and provide service mesh configuration at a single place, and it gets pushed out.
Yeah. And Ram, very, very tactically, if you're migrating from Sidecar to Ambient and you've upgraded Istio to the latest version, what's the implication? Let's say you're an operations engineer, you've got a pod that's using the Sidecar method. Very tactically, how do you go from Sidecar to no Sidecar?
That's a good question. I think like what we're seeing is that, so Ambient is currently alpha and soon to be beta. And then at Solo, we provide a GA distribution of Ambient. So we're behind our customers to make sure that they're able to move to Ambient immediately. What we're seeing is that new workloads that are being added to the mesh are going to leverage the Ambient model. The workloads that are already on there that are part of the mesh, if they're using sidecars and they're happy with it today, don't mess with it. There's no reason to. The next time you go to re-architect, you can think about testing without a sidecar.
Got it. Makes sense. Okay. One more question before we jump to your demo, Ram. How many Waypoint proxies are needed per node/cluster?
That depends on the number of workloads that are on that node or cluster. So the number of waypoints, it doesn't. You would create a waypoint per your workload. It could be a set of workloads, but typically you would carve them out by maybe you'd have one per namespace is something that like a common approach that we've seen, and then have all the workloads that are part of that namespace share that waypoint proxy. We've also seen per service account. It really kind of depends how your teams are doing tenancy within the cluster.
Got it. And Ram, you mentioned Ambient is right now it's not GA, but Solo offers a distribution that's fully supported for using Ambient. Okay. Got it. And just so folks are aware, Solo.io is one of our trusted partners in our EKS marketplace of add-ons. So you can even start working with Solo.io using our marketplace EKS add-ons integration. We think we've really streamlined that workflow. But okay, Ram, I think enough chatting about architecture. Let's see how this stuff works.
Okay.
Share your screen here.
This is where it all goes downhill, huh? All right, let's see.
No pressure.
Yeah.
I'll only give you crap in person this weekend if something goes wrong.
This crashes and burns. Yeah, it's okay. The demo is very, very simple. Like that's the point of Ambient, right? Like it's meant to be simple and transparent. So there's not much complex things really I could show with Ambient, and that's the way it should be. So you see my screen? You see this little like book info diagram? Yeah. Okay. Cool. Yep. All right. So what I'll do is I'll deploy the book info sample that people are used to, that Istio users are used to, right? This is the classic example that comes with Istio. But this time I'll show it with Ambient. There's a front end application called Product Page. It talks to reviews, and there's 3 versions of reviews: V1, V2, and V3. V1 has no stars, V2 has black stars, V3 has red stars, and there's a couple other microservices. That's kind of all you need to know. So what I'll do is I have a couple of clusters. I have this cluster called Ambient 1, and then I have another cluster called Ambient 2, and I'm going to deploy book info and Istio and apply some layer 4 and layer 7 policies. I actually already have the book info samples already deployed, and you can see they don't have a sidecar. In fact, I don't even have Istio on here. So it's just a cluster that does not have Istio and has the book info sample application, no sidecars. The first thing I'll do is I'll install Istio, and I'll use Glue to do it. So with Glue, we can define using Kubernetes CRDs exactly how you want your Istio to look like and in what clusters. So we have this Istio Lifecycle Manager object. Think of this as like an abstraction on top of the Istio Operator API if you're familiar with it. And you can say that on cluster 1 and cluster 2, I want you to install Istio 120, get it from this location, and install the ambient profile. So this will install Istio on both my clusters. I will also use the Gateway Lifecycle Manager to install the Istio Ingress Gateway, again on both of these clusters. So this gives me a declarative way to say, hey, I want you to go install Istio. So kubectl apply. Okay. So now I've installed Istio Lifecycle, Istio install Gateway Lifecycle. So now if I go back in here and give it a, like, I don't know, yeah, you can see within a couple of seconds, we start installing Istio. So here's the Istio control plane. I have a 3-node cluster, so I have 3 Z tunnels. So they're popping up. If I run this command on my cluster 2, I should probably see the same thing as well. There. So cluster 2 also is spinning up. So now I've installed Istio, right? Next thing what I'll do is I want these pods, these book info pods, to be added to the mesh. To do that, all I have to do is, hold on, kubectl label namespace. Yeah, I am labeling this book info. I hope you can see this okay. I'm labeling this book info namespace with this tag that says I want ambient data plane. That's it. These workloads, these book info workloads now, they're part of the mesh. Like now when they talk to one another, they're using MTLS. So let's start using this application. So the next thing I'll do is I'll expose book info. So, make it available on the internet. I'll create a virtual gateway resource. So this is equivalent to like an Istio gateway resource that says, I want to program the Istio Ingress gateway, listen on port 80, listen on all hosts. And then from there, if it matches product page, static, et cetera, then I want you to route to this product page workload, right? So think of this as your Istio gateway and virtual services. So I'll apply that resource. So underneath the covers, what Glue will do is it'll take these resources and write the Istio gateway and virtual service resources automatically. So if that goes well, if I hit refresh here, I should hit my apps. There it is. So here's the book info application. I'm hitting product page, and product page is talking to reviews V2. And remember, V2 is black stars. But if I hit refresh, I should jump between other versions. So here now I got V1. If I hit refresh again, V1, it's kind of hopping between the different versions. So back to V2, etc. So that's me using the service mesh. I have workloads that are part of the mesh, and I'm using Istio Ingress Gateway, all without ever touching my my pod. I didn't restart it or anything. Those Z tunnels. So now traffic is going from Ingress Gateway to Z tunnel to product page, to ztunnel, to reviews, etc. So now I can start creating access policies. So if I say, so here's an access policy that says that for the details application, only the ratings application is allowed to talk to it. So let me go ahead and apply this.
So Ram, I've got to ask, how do you know which one of these configurations are supported when running an ambient mode versus sidecar mode versus ambient with Waypoint proxies? There's a lot of different buckets where you have these features exposed.
Well, ideally, like the API stays the same between, for a majority of the cases, these route tables, these Istio virtual services, gateways, etc. It supports both. So there should not be any changes you need to do for the main feature sets that Istio provides.
Okay.
If you're using the Glue API, which is an abstraction on top of it, then you just get further interoperability between different versions of Istio, et cetera, et cetera.
Got it.
So I created this access policy that says only ratings is allowed to talk to details, right? If you go back to the diagram, we just said ratings is allowed to talk to details. So this line that doesn't even exist. So if I go back to my app, things will be broken, right? Because product page is not allowed to talk to details. So I made a mistake, right? So like what I meant to do here is do product page is allowed to talk to details. So if I go apply that, configure, go back and hit refresh, boom, it starts working again. It's instant. So now I'm able to create explicit access policies instantly and configure who's allowed to talk to who else. So that's a simple, layer 4 access policy.
So Ram, you could also do this with Kubernetes network policies. Would those continue to be honored? And why is this approach, any better or worse than using network?
So with Kubernetes network policies, it's using IP addresses essentially to create these strong boundaries between these various different teams. So you can still use network policies. With Istio, you can do layer 4 access policies. So you can you can select by service accounts, and then you can also say things like, if on this particular port when you have this header, when you have this JOT token, you're allowed to talk to details. And that's stuff you can't do with the network policy. With Istio, because we have layer 7 functionality, I'm not showing it yet, but I will shortly, you can do those more fine-grained, more powerful policies on who's allowed to talk to who and under what conditions.
Okay, got it. And very quickly, I just want to pull up the Lightboard again because I want to talk about one thing. So what you showed now was kind of a very basic routing policy. So that can happen without, kind of an authorization policy. That can happen without Waypoint proxies. It can happen
I don't
just
have any Waypoint proxies. Yeah.
Right, so no Waypoint proxies deployed just yet.
Yes, correct.
Okay, so that's what you're going to show next, I presume?
That's correct, yep.
Yeah.
Can you see, you can still see my screen okay?
Yep.
Okay, cool. All right, so the next thing, I actually just applied this, but this is the layer 7 policy. So now we're saying that for anybody that is calling reviews, using this host name in my cluster, I want them to only go to version 1 of my service, right? So with reviews, I had, 3 different versions of it. So now we're being more explicit and saying that, hey, now I only want you to send to this subset. This is where I can get more complex, right? This is where I can say, add this header, validate this JOT token, or on Chrome browsers, go to version 1, on Firefox, go to version 2. Or I can do percentage-based routing, send 5% of the traffic to version 3, etc. I'm showing a simple policy here for the sake of a demo, but this is where you can start adding additional logic. So I applied this layer 7 policy just now, but if I go back to my console and look at the pods for the book info namespace, look what happened. We dynamically stood up a Waypoint proxy just for reviews. So because the reviews team is now being specific about their layer 7 configuration, we stood up a layer 7 proxy just for reviews application. So now if I go back to my app and hit refresh, I will always just get v1.
So Ram, I've noticed there's only one instance of that pod. That doesn't seem very highly available. Is there a way to configure the number of these?
Yeah. With Waypoint proxies, I mean, just like anything else in Kubernetes, right? So you can attach HBAs, you can do affinities to make sure that they're scattered across multiple nodes. All those functionalities are available to you. So I'm just showing you the default, which is to spin one up. If this team says, "Oh, I don't want a layer 7 policy anymore," all traffic is allowed to talk to me without any manipulation. And I go back to and I list the pods again. You can see that it went away. The Waypoint proxy went away. And now we're just going straight back to the previous behavior where we're round robining between everybody.
Got it. So clearly we have some operator, some the Istio control plane listening for the CRD to exist. And the second a CRD exists with an L7 policy, it kicks off the creation of these Waypoint pods. So realistically, from a GitOps and operationalizing perspective, the operations team just needs to stick that L7 policy in their GitHub repo.
Yeah, you can. I'm being in production. So underneath the covers, what Glue is doing when I create that layer 7 policy is that it's creating a Kubernetes Gateway API gateway resource and telling IstioD to spin that up. If you know for a fact that it's going to have policies and you don't want to rely on this dynamic behavior, then go ahead and create that gateway class, that gateway resource, and stand up that dedicated Waypoint proxy that's going to be there at all times.
Got it. Actually, that was going to be my next question, because without knowing which pods are going to spin up, you can imagine that maybe you have some auto scaling mechanism that initially scales your cluster up without the waypoints, and then the waypoints get spun up and it's like, oh crap, I need to readjust the number of nodes.
Yeah, exactly. So you might want to have a static number of waypoints just to have a more predictable behavior.
Got it.
Yep.
That makes sense.
I'll kind of end my demo showing the dashboard where we just installed Istio. The Glue Mesh dashboard, we installed Istio across these two clusters. Now I can see my workspaces and see what workloads that are part of this mesh. And then, all the policies that I created. Here's the north-south gateway. Here's the product page route table. Here's the policies where we lock down details. And then I will finish the demo by showing a graph, of the book info and the Istio Gateway's namespace. So you can see this is live traffic that we just sent to the book info application. So here's ingress gateway hitting product page, and then product page was hitting v1, v2, v3. You can click on any of these lines to see that it's mutual TLS enforced by Istio. Cool. All right. So back to you. Hope that was helpful.
That was very cool, Ram. Thank you for that demo. Now, very quickly, I just want to point out I found a blog about Istio's Solo.io's Istio integration with Amazon EKS, and I looked at the author, and it was you. So, Ram, just plugging your blog here, but really, folks, make sure you check this out to see that integration between Amazon EKS using our add-ons framework to get Istio going just a little bit easier. And of course, Istio Ambient Mesh, whether or not you're working with kind of Solo's distribution of Istio, it's an open source capability. Ram, can you speak a little bit to why use Solo.io's distribution of Istio?
Sure. Solo's Glue Mesh, it is enterprise Istio. We don't fork it, but all we do is we work upstream and then we do our own builds of Istio. What that allows us to do is support Istio versions for a longer period of time. So upstream Istio, N-2 every 6 months or so, you have to keep upgrading to get the latest CVE patches. With us, we let our customers stay on a particular version of Istio for about a year and a half, and they can get CVE updates, etc. If there's anything wrong, any code changes that they need, we're able to spin them out a new build pretty quickly. And we're also Solo led or co-led the whole ambient effort, right, in the community. We've innovated. We're very proud of the ambient mode of the Istio service mesh. That's why we were first to make it available GA for our customers, because we want to battle test it. We have a lot of Istio users. We want more Istio users to try out ambient. We want to work upstream to make Istio ambient beta and GA so that everyone can try it out. and then this, forget the sidecars, and then move on to a sidecarless architecture for Istio.
Okay, and you said this a couple of times that you see that in the future ambient really does take over, but I think people might be concerned, like, hey, I use sidecars pretty heavily right now. Should they be worried?
No, absolutely not. There's nothing that, but all the users, right? Like 99% of the users right now are using sidecars. There's nothing to worry about. Sidecars will be supported and will stay there for a while. Yeah.
Okay.
Like I said, ambient is still like alpha and upstream, but quickly getting to beta.
Makes sense. Okay, Ram, we got one question for you, and unfortunately, I know the answer to this, but are we going to see you at KubeCon?
Unfortunately, no. I can't be traveling internationally right now. I have a new baby, so I should.
Yeah. Okay. No, that's fine. That's totally acceptable when you have a 3-month-old.
Yeah, exactly.
So yes, 4-month-old actually.
Yeah.
So Ram, how can people get in touch with you? What's the best way? Do you want them to add you on LinkedIn or?
Yeah, LinkedIn would be perfect. Yeah. Look me up on LinkedIn. I'm available and like the CNCF Slack. You can find me on the Solo Slack, or you can email me at ram@solo.io.
Yes, awesome. And yes, I love the fact that we get to collaborate, Ram. Hopefully I'll bring you back on the show again sometime soon. Probably going to be about Istio again, but this is a very kind of common and popular topic for our customers. So really glad we were able to kind of cover this architecture. Very quickly, I'm going to go dip off the screen. So if someone wants to take a screenshot in the recording, here's where you could do it. And Ram, thank you so much for joining us. For our folks watching at home, want to catch more content like this, be sure to subscribe to twitch.tv/AWS and Containers from the Couch on YouTube. Thanks so much for tuning in. We'll catch you next time, folks.
Bye, everyone.